Okay, experiences with the integration of DTMs. I mentioned this already. We had at the beginning a very, very big problem with the memory consumption of DTMs. So we have host applications which are requiring already a lot of memory. So 500 megabytes up to 1 gigabyte is not very seldom, unfortunately, for our systems, for our programming and engineering systems. So if you have then DTMs, which are again consuming 250 megabytes of memory, you can imagine that it's not possible to open more than 2 or 3 of these DTM until you will reach the memory limit of your PC, of your computer. So we had to go back to the DTM developers, or to the departments who were developing these DTMs, and had to say, hey, come on, your DTMs are running in a system. We have systems with 50, 60 or 100 devices at one time, and we are not able to handle such big memory consumption inside your DTM. Then unfortunately, we had a lot of problems with memory leaks in DTM. So, for instance, if you are updating a catalog, every DTM is instantiated on the system, and if you have finished the catalog update, still some memory were occupied, or the memory was occupied, and this led also to something like a memory fragmentation, and after some time there was not enough memory for the system itself available. So it took us a long time to get some DTMs, especially FDT1 DTMs, native C++ DTMs, to a state where they had no memory leaks. This is a message for the DTM developers here. It's really for a system supplier, it's really a big problem if you have DTMs either consuming a lot of memory or having memory leaks, because they have to handle this somehow. Then we had at the beginning also problems with the performance. In some DTMs it took up to 20 seconds to start such an DTM. Again, this sounds not so much at the beginning, but again, consider you are using a machine with 10, 12, 20, 50 devices, and every device needs 20 seconds to start up its configuration screen. It's really horrible for the user. Then the saving and the loading of the persistent data took often very long, and the size of the instance data set of some DTMs was also sometimes very big, and this is really a problem for some Schneider systems, for instance, because we are trying to save these instance data sets, these configurations on the PLC, so that an engineer is able to upload the complete configuration from a machine directly from the PLC to the system without the need to have the old project of the engineering system. And if you have instance data sizes from, I don't know, 5 megabytes or 10 megabytes, and this for 50 devices in the complete machine or in the complete plant, this is not possible with usual PLCs or Schneider PLCs, which have only a few amount of memory available. Then we had a lot of problems with blocking the communication, where the communication was suddenly blocked. We got so-called connection loss errors. So this happened during network scan on the one side, but also during the cyclic communication of a DTM with the device. And after a lot of investigation and consultant from M&M and from other departments, we found out that this is This was mainly a threading problem between the device DTM and the communication DTM, and in some circumstances the message queue was blocked, the Windows message queue was blocked, and no communication was possible. Then important for our system, we had really problems with very poor process channel support in DTMs. So for our engineering system, it's very important that DTMs are providing channels, because we want to integrate these devices into the process, into the cyclic I/O communication. And for that, we need the information, which kind of I/O signals does the device provide, which kind of process data information does the device have. And this information comes out of the DTM, and the system, the master DTM and the engineering tool itself needs this information, which data is available. Unfortunately, we found DTMs with poor process channel support on the market, and the same with the bus master configuration part, so the network configuration part of a device. So for instance, for Profibus, where we had a lot of problems that the device DTMs were not providing a correct bus master configuration part, and it was not possible for us to set up the cyclic communication of a Profibus master, because the information coming from the device DTM was somehow faulty or not complete or whatever.
I don't know, 5-6 different devices, and third-party devices, third-party devices have different representation of the bus master configuration, because these DTMs were developed before the best practice document when the FDT book was out at that time. So therefore each developer implemented it somehow a bit different. So we analyzed bit for bit and all these devices, and every time there was something different.
So I told you a lot of maybe maybe it sounds like a lot of negative experiences we had, but nevertheless we see also a lot of advantages to use the FDT container and the FDT technology itself in our system. Especially the usage of the FDT container component from M&M is for us very important, because it is something like a de facto standard on the FDT DTM market. So I think more or less every developer is trying to use or to test his DTM inside the M&M container. Especially now for FDT2, where FDT container is a common component, so where it's the standard for FDT frame applications. So we really have less interop problems inside Schneider, because every product department, every system provided by Schneider is using this one frame application implementation. This is really a big advantage for us. So the reuse of a DTM developed for SoMove is more or less guaranteed in other applications like SoMachine. Of course, we save a lot of investments due to the reuse of this FDT container component in several applications. We really have to say, and to be clear here, that the FDT container component is a very, very stable frame application from our point of view. We detected only a few bugs. It was always very, very good backward and forward compatible between old and new versions. And if there were really bugs or problems, we found in M&M a very good partner, who has a very good responsiveness. If we are reporting problems, we were delivered very fast with bug fixes for FDT container component. Also, the mini frame example, which is provided together with the FDT container component, was very helpful, very useful, because developers can have a look into an example code, how this container component can be used, and the trace mechanism provided by this component was also very helpful for the developers, because it's tracing all the FDT state machine transitions, for instance, or some FDT method calls and so on. Okay, finally a short outlook to the migration we have started from FDT1 to FDT2, and here I want to look especially again to this Unity application, because it's still a C++, a native C++ application, and at the moment there are no plans to change this, so this application will exist several years also in the future. But the FDT container version 3 for FDT2 now has only .NET interfaces. There's no access possible via COM interfaces from a C++ application to this .NET component. There are good reasons to do this. That's clear for us. It's because of the change to the new FDT2 technology with this .NET interfaces and so on. But nevertheless, we have a native C++ application, and we want to use also FDT2 in this application. So what we are doing right now is we are developing a so-called COM wrapper. It's a wrapper around this FDT container component version 3 for FDT2, which provides then again access for our C++ application to the FDT container component. So this COM wrapper somehow provides a COM visible API of the FDT container component. This is what we are doing right now in order to be able to integrate the new version, the new FDT2 version of FDT container component into the Unity application.
When do you think users will be able to have this, so they could use FDT2 DTMs?
I think what we know today is Yokogawa is working heavily on FDT2 for the frame. So they have already a prototype. They will begin next year in frame. The feed care is another is integrated. It should be available soon. For others, I don't know.
But for yours, that's a couple of years, or?
So the actual plan is that we will integrate the FDT container component during this year into Unity. When the official release will be, I don't know, maybe it's already next year, but...
maybe end of next year, depends. So this is the final decision of the product departments. So for example, we are also developing new drives, and we have to decide, do we go use the new drives to FDT2, the DTMs or not? And unfortunately, we have to use FDT1 because the annexes we want to use CRP, and thus we are not ready at the moment. So we could not guarantee them the time to market with the DTM based on FDT, because FDT2 DTMs is a huge advantage, because we have this common component developed in the FDT project, where all this, based on this experience, where all the threading mechanism and all the things are encapsulated in this component, where you don't care about all the details of the FDT specification when you use this component.
Okay, a last slide between me and your coffee. So all other applications inside Schneider are based already on .NET, and there we have no real challenge to integrate the FDT container component for FDT2. We already checked the differences in the interfaces, and it seems to be more or less easy to migrate from FDT1 to FDT2 for us in existing .NET applications. But one future issue or challenge we have to solve is the 64-bit support of FDT container component. Today we have already the request because of the high memory consumption of our engineering systems for using 64-bit systems with higher memory available on the PCs, but the FDT container component today supports only 32-bit because of the backward compatibility to FDT1. This is a thing which we already addressed at the change control board for the FDT container common component, so where discussions are already going on, and where we are working on at the moment.